Alrighty, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Walker Graham Middle School. And in this video, we're still working on that SOL review guide. And we're now on that SOL 7.4. And so what it's talking about with this one is we're working with those problems talking about volume and surface area of a rectangular prism, which is kind of like a box, and a cylinder, which is kind of like a can. Make sure that you are using that wonderful formula sheet for yourself. And what I can actually do is I can say, all right, I have my rectangular prism, volume, surface area, and I have my cylinder, volume and surface area, and I'm actually going to write those on the side here for you. So let's say here, so I have here rectangular prism. For volume, actually let's do it for surface area. It's going to be 2 times the length times the width plus 2 times the length times the height plus 2 times the height times the width. And then for the volume, we have length times width times the height. Again, make sure you are very careful. Again, this is for rectangular prism. And then for a cylinder, we are saying we have the surface area is going to be equal to, again, just let pi equal 3.14 for this. That way it's a little bit easier. But you could say, all right, I have 2 times pi times the radius squared plus 2 times pi times the radius times the height. And then for volume, it's just going to be the area of that base, pi times the radius squared times the height. All right. And what I want to have these for is because when I go to type these into Desmos, I want to make sure I'm doing the right ones. Again, these are super helpful because when you're using that Desmos Calculator, it becomes a lot simpler. So let me actually, let's do that. Let's say, all right, I have, for number one, I say a cylinder has a radius of 7 inches and a height of 20 inches, which is the closest to the total surface area of the cylinder. All right, so for a cylinder, again, we're going to have that surface area, so we're going to use that 2, and then we have times that 3.14, and we're going to say times the radius, which I need lowercase, there we go, r, and then we have squared, and we're going to say plus, and then we have 2 times that 3.14 times the radius times the height. Again, on the right side, using that Desmos Calculator, it's saying, hey, I need to define what those variables are before it can give me the surface area of that cylinder. And so I'm going to say, all right, I have r is equal to, let's have equals, then I have h is equal to, all right. And then so let's do that. Let me actually just use that, make sure it's still on screen. All right, so the radius for this is 7 and the height is 20. That means our surface area is going to be about, so it gives surface area is exactly 1186.92, which is closest to C. All right, for number 2, it says, which of the following dimensions will create a rectangular prism that has a volume of 240 cubic meters and a surface area of 248. So again, we're talking about a rectangular prism. So what I can actually do is I can clear these out. We have still equals. I can clear out those values, but I can still save those in there. That way I know I'm going to be using them later. So what else do I need? So this is going to be, so that's surface area. Let's put volume in here just in case. So we have, for the volume of a cylinder, it's going to be that 3.14, and we have radius squared and times the height. And then for, what else do we need? We need for our rectangular prism, we have the length and we have the width. All right, two formulas for that. We have 2 times the length times the width, and we have plus 2, and then times the length times the height, and we have plus 2 times the height times the width. All right, and for our volume, again, it's just going to be those 3 multiplied together. So length times width times height. Again, that's only for the volume of a rectangular prism. All right, now that we have those values, again, we can just type it in and let's see. So we're looking for this. We're looking for a surface area, which is going to be that first value here. We're looking for a surface area of how much? We have 248, and we're looking for a volume of 240. So make sure that you are seeing those carefully. So now we can try out this first one. We're saying, all right, we have let's actually switch these. Yeah, that's fine. We have easy now. We have a width of 6. We have a length of 2 and a height of 20. So again, I can scroll down and see, okay, I have a surface area 344 and a volume of 240. We have the volume, but we do not have that surface area, so we're going to say no to that one. All right, we can clear those out. All right, what about a height of 10, a length of 4, and a width of 6? We have a surface area of 248, and we have that volume of 240, and so we are good with that one. Then for number 3, it says a cube could be made using the net below. What would be the total surface area of the cube created using the net? So again, make sure you're saying a cube has equal sides. And you notice that actually by saying this, we're saying, okay, if this side length is 5, that means that this area of this one square is 25. That means that we have, well, how many total squares? We have 1, 2, 3, 4, 5, 6. So we're saying, all right, we have 25 plus 25 plus 25 for each of these. And so since we're talking about surface area, we're going to say that would be 150. Again, that's for surface area only. If it was volume, it would be 5 times 5 times 5, which is 125. Again, be very careful of what it's asking for. All right. So now we can actually double check using that Desmos Calculator because I like to do that. Let's have back the length, the width, and the height are all 5. Oh gosh. This was R, and this should be 5. All right, so yes, notice how our surface area is 150 and our volume is 125. Moving on. We have the right page here. There we go. For number 4, it says soup is stored in a cylindrical container that has a radius of 3 inches and a height of 8, which is the closest to the maximum amount that it can hold. So we're looking for volume on this one. Again, we have our height and radius, and so let's say our height for this one is 8, and our radius is 3. So we're looking for volume. Again, make sure that you're saying, I like to have, if I'm saving those in there, be mindful of which ones are which. So I'm saying that this is my surface area, but this is my volume. So I'm saying my volume for this is 226.08. So I'd say 226.08 for my volume. For number 5, it says Melly bought a fish tank that is the shape of a rectangular prism for her living room. Which statement would help her figure out how much water she will need to fill the tank? Since it's talking about filling a tank, we're talking about volume, so we can already cross out those two. However, be careful. We're saying, okay, which of these is a true statement? Well, we know that C is not correct because that is not the formula for volume. However, D is the correct one. For number 6, it says Grant is creating a new cylindrical pole for the sail on his boat. He will melt the metal down to form a pole and then paint it. The pole will be 16 feet tall and have a diameter of 6 inches. Which of the following statements are true? So it's now talking about, okay, you'll need to calculate the surface area and you'll need to calculate the volume. But depending on the situation, you have to be very careful with it. So let me double check and make sure I have those values in here. So we're saying this, we'd say, all right, he needs to figure out the surface area to figure out how much metal to buy. That makes sense to me. He has to figure out the surface area to know how much to paint, and he would need to find the surface area of how much space it would take up on the deck. However, with the others, he wouldn't need to know for that. For number 7, it says one way to determine the surface area of this cylinder, again, surface area of a cylinder, so is this. We have, it says add the area of both bases to the rectangular area around the cylinder. Well, let's see, what does that mean for us? Well, very simply, that means this. Let me actually try to draw this picture. If you think about it, when you draw out the net, of a cylinder, it kind of looks like that division sign. So we have that rectangular, that's that lateral face, and then we have the two bases. And so I was saying add the areas of both bases and the rectangular area around the cylinder. So we're gonna say that's actually that first one. You can make sure that you can picture what those look like. For number 8, it says, excuse me, Carl is covering the rectangular prism-shaped box with cloth. What is the minimum amount of cloth it needs to cover the entire box? So since we're talking about cover, that's talking about surface area. So let's use those dimensions. Again, as long as you stick to those values, you will be good. Excuse me. All right, so we said, I can say, I can use 12, I can use 2, and I can use 8. And then my surface area is going to be 272, I'd say, inches squared. Then lastly, it says the swimming pool is 50 meters long, 25 meters wide, and 3 meters deep. Excuse me. As a liter is the same as 0.001 cubic meters. How many liters of water are needed to fill the pool? So what I can do is this. I can say, all right, I have 50, I have 25, and I have 3. So then my volume is this, but it's saying, okay, how many liters? So it's giving me 0.001, and so I'm going to need to now multiply. So I'm going to have to multiply by how much? Not 100, but I'm going to have to multiply by 1,000. So I do times 1,000, and so yes, it is going to be that 3,750,000 liters.